In my experience, whenever I've sat down to learn a new technology, sometimes it could be useful to occasionally pause and look at how things are working behind the scenes or understand the underlying design principles that go into the technology, because once we understand that, it can really enlighten how we're working with that technology and how we're understanding it. So with that in mind, let's take a moment here to just look at some of the underlying principles that guide the Vue.js framework in terms of how it works behind the scenes, starting with things like the virtual DOM. The virtual DOM is a popular technique you'll see in lots of JavaScript frameworks, and the idea is to optimize the efficiency in which we can update content on the page. Now, to understand what the virtual DOM is, let's rewind and talk just about the DOM in general, or the document object model. Every web page we view is based on the document object model, where we have these HTML elements that create a tree-like structure of our content. For example, I have a very basic HTML document here, and as we know in HTML, we work with these nested elements, right? So the outermost element is this HTML element, and then inside of there, we have the head element and the body element. Then looking further within that, within the body element, we have an unordered list, and then that unordered list contains a list item. If we visualize this in a tree-like structure, we can break it down like this diagram, right? So the HTML is the outermost element, then the head and the body, and then again, the body is broken down further into this unordered list. So that's the basic idea of the document object model, this tree hierarchy type structure that is formed by our content. And then when we want to update it, when we want to change our interface, we can use JavaScript to do that. And I've got a basic example here of what this would look like in vanilla JavaScript, where you might come up with a new list item, and then using the DOM API, we can target things. So here we would target the UL with the class list, and then we could add our new list item to it. And for a simple example like this, that would be plenty efficient. But imagine multiplying this, thinking back to in part one of the series, we talked about web applications like Google Docs. And something like that, you might have hundreds or even thousands of elements within your page, and you might have programmed into that hundreds or thousands of DOM manipulations for that interface. At a certain point, you would start to notice some performance kind of costs or lagginess to the interface, because every time you're working with that DOM and manipulating it with JavaScript, there's a processing cost that comes with that. So one way to address this and to speed up our interfaces is to create a virtual DOM. And that's what Vue.js does. And like I said, a lot of other frameworks do this as well, where basically they create a JavaScript object with a mapping of your document structure. And then when you call to manipulate that structure with your Vue code, what it'll do is it'll first look through the object and kind of almost plan out how it's going to go about doing that, finding the most efficient way to do it, including if you're asking for multiple things to change, it can potentially batch together those changes. And then, of course, once it's done with this processing, it will actually manipulate the DOM itself, but it really tries to minimize the amount of manipulations it has to take, thereby making your application more performant. So the virtual DOM is kind of key thing number one to understand about how frameworks like Vue.js works. Moving on, the next thing that I want to emphasize is the reactivity system. This was something we actually saw an example of in the previous video, where we had things like our answer data property. And we saw that wherever we were using that, it was always going to be kept up to date. Right. So for example, we had a text input that was modeled after the answer data property, and then later we output it to the page. So anytime we change that value via this input, we automatically and instantly saw those changes reflected here where we output it. Another example where we saw reactivity, things like our show feedback div down here. On initial page load, show feedback is false. So we didn't see this div, but then via our check answer method, once we click this, that updated our feedback data property to true, and then automatically our interface was updated to reflect that. This div then appeared on the page because it was reactively listening for changes to that data property. So those were good examples of the reactivity system in action. And if you want to know more about how this is working behind the scenes, I do have that information in the notes. I've summarized it and also linked over to a page in the Vue documentation that breaks it down into more details. But for our purposes, we don't have to concern ourselves too much with how it's working. We just have to understand that it is working and understand how that's going to impact the code that we're writing. And this actually brings me to the last point I want to make in this video about how frameworks like Vue really change the paradigm about how we're programming our interfaces from an imperative style to a more declarative style of programming. And if you're not familiar with these terms, let me break it down. When we talk about imperative programming, we're talking about being very specific in what we want to happen. And I share here this metaphor of, let's say you were asking someone to get some eggs. The imperative way you could do this would be to be very specific about each step that would be required to do that. Now, contrast that to declarative instructions or declarative programming, where you're going to be much more broad, much more general. You're going to focus on just the end result, which is simply bring home eggs. You're not going to spend time breaking down the individual steps necessary to make that happen. Now, prior to JavaScript frameworks like Vue.js, typically the way we programmed our interfaces was in a very imperative style. And I have an example of that down here, where we can imagine a game interface where the first thing we do is we ask the visitor to type in their player name, and then we output that to the page. Kind of similar to our previous example where we ask the user for their answer and then we immediately output it. Same thing here. If we were doing this without Vue, we would write this in a very imperative style where we would first have to explicitly target elements on the page using that document object model API. And then we would have to explicitly say, okay, for our name and input, let's attach an event listener to it so that anytime it changes, we could update our name output here, reflecting the new value. Right? This is very explicit and detailed in terms of targeting the elements on the page, listening for changes, and deciding what should happen when those changes occur. Now compare this to a more declarative, a more general style of programming where we set up our input and we set up our output, and we're not doing anything in terms of setting up event listeners or explicitly saying, okay, when player name changes here, we need to update it here. All of that is really abstracted by Vue.js. Because of the reactivity system, we have this value player name, and it's just going to be listening for changes to that so that when it changes in the input, we'll see those changes reflected here where we're outputting it. The end result is it really simplifies our job as programmers because we don't have to worry as much about the how or the specific details of what we want to happen. We can really just focus on the interface, the data properties within that interface, and wire everything up so that behind the scenes, Vue is going to take care of the interactivity for us. So now that we understand the difference between these two programming styles, let's talk about why. Like, why does this matter? Why should we be thinking about this in this stage of our learning about Vue.js? And the reason is because I find that often JavaScript developers that are new to JavaScript frameworks, you really have to switch your mindset to the declarative programming style. Because if you don't, you're going to find yourself in situations where you're going to try to write code like this, right? You're going to try to be very specific about what you want to happen in the interface. You're going to try to add event listeners and things like that. You're going to try to directly manipulate the DOM. And those are all things you don't need to do when working with Vue and things you shouldn't be doing because as we saw, or as I was talking about earlier, Vue uses the virtual DOM. So it's going to do those manipulations for you. It's going to do it in the most efficient way. So it's not something that you should be directly working with. Instead, you really want to shift your focus to the data of your application and think about how that needs to be manipulated and let Vue handle the details of reflecting those manipulations in your interface. And with that, that's all I want to say right now about big picture behind the scenes, what Vue is doing. We've talked about the virtual DOM, course, your activity system, and then how this all ties into this shift to a more declarative programming style. And I want you to think about these in the coming videos and the coming examples as we're designing our interfaces and our applications. Think about how these things are playing into that. Before we wrap things up, though, I do want to go over the solution to the practice exercise I left you with at the end of the previous video. So let's switch back to our code editor. And the task was to add a reset button to our interface. And this is actually a good opportunity to start to think in that declarative style programming where instead of worrying about the mechanics of the button to begin with, let's focus on, well, what needs to happen to the data in order to reset our interface? And the things that I can think need to happen are things like our answer data property needs to be set back to its initial state, which was just an empty string. Similarly, the other data property that gets changed is show feedback. That gets toggled to true when we check our answer. So to reset things, we would want to set it back to false. right, so to address that, let's actually create another method. We could just call it reset, and we'll make those changes. So we're going to say this.answer, and we're going to set it to an empty string. And then for show feedback, we'll set this back to false. Then coming back to our template, we'll add a button to trigger that method. So I'll just copy our existing check answer button, and we'll change our click expression here to reset. And then we'll change the label of the button to reset. And in thinking about the placement of this, the way we've written it is we're always going to see the reset button, which that's not necessarily something we need when we first come to the page. So what I think I'm going to do, I'm just going to move this inside of our show feedback div. So we'll only see the option to reset once we've actually checked our answer. All right, so let's go check this out in the browser. Let's refresh it. All right, great. So here's our starting point. We don't see the reset button, but we go ahead and enter our answer. We click check answer. And then we've got our feedback and then our reset button. So let's try it out. And perfect, we're back to our starting point.